of Solidity Fridays. We are joined again by the great Paul from Sablier, and is going to go into some smart contract with us about the Lockup Dynamic. And Tam has joined us again, one of our Web3 Sanctuary instructors. So yeah, I'll hand it over to you guys.
Thanks, Rebecca. Yeah, I was telling everyone I've been really excited for this episode because as far as I know, Sablier is the first protocol where you can stream money in the customizable fashion with an equation. Yeah, how did you come up with that idea?
First, very happy to be here. Thank you for having me. And what Lockup Dynamic is, as you say, the first nonlinear streaming contract, to my knowledge, in existence, not just in crypto, but in the whole of finance. And the idea was we were talking to users and our like Sablier V1 users, and there was one user who said, "Hey guys, do you support incremental streams whereby they're like want to have like a vesting plan on chain, and they ask us, we want to have this model where in the second year you have 10% more tokens released, and the goal being to incentivize the employees to stay with you for for many years, and their reward gets bigger, quadratically bigger the more years they spend with you." And V1 couldn't handle this. And we thought about it and said, one way to implement that is to just have a naive, like, annual increase where we let people say, I want in the second year to have 10% more, in the third year, I want to have 20% more, and so on and so forth. But then we thought, oh, wait, like, why wouldn't we want to make it universal? Like, the annual release is just a special case of a payment system that can take any mathematical function. Yeah. And I happen to have this background with, yes, exactly, yeah. And just to end on this note, I happen to have this background with math and Solidity. I built this math library called PRB Math. So it just all made sense in our heads to pursue this universal payment engine path.
That's amazing. I'm so glad you did. I'm so excited to use it. I've thought of a few use cases already, and I've been getting really excited. Yeah, and it's so cool because a lot of DeFi things port over from TradFi, but this is new in both realms. So I'm really excited. And it's very well tested and documented. So I'm really excited to see what you show us today.
Thank you. Just to quickly follow up on that note about being new, as we discussed offline, I have this view of there being a spectrum of new things, and most things in DeFi, they're just implementing TradFi contracts in a decentralized manner, and I love that. But I think what we did here is that we're at the extreme edge of something being new, where this contract doesn't exist there, but it exists in DeFi. And I do want to emphasize this point because oftentimes you hear non-crypto folks dunking on crypto, saying that it's all scams, it's all whatever. No, there is innovation happening, and there are new things being built. And I hope that Lockup Dynamic will be like something that people will pay attention to in the future and implement all kinds of iterations from what we built here.
Speaking of which, you mentioned it's great for vesting where you can increase by year. What are some other nice use cases? I suppose airdrops is one.
Airdrops is one whereby you want to monitor your community, and those who don't vote in your governance forum or don't remain engaged, then you cancel. We cancel the stream, and therefore only those who stick to the end of the 3 to 4 year airstream. We like to call it airstream, by the way, but airdrop anyway.
That makes sense. That's cool.
Thanks. And just at the end, they will get the entire reward. That's one thing. Also, things like contribution for grants, whereby so you want to suppose you're a DAO and you want to give out a grant to like a new project. You don't necessarily know how committed they are. So what you do is you create these like nonlinear payment curve whereby in the first month they get X, in the second month they get X times 1.1, and so on and so forth. And the idea is to have to build a relationship that pays you more tokens the longer you stay committed to that relationship. So in a way, it's like compounding, payments for relationships between parties, like long-term relationships. And these are just the initial ones, but I can envision some futuristic cases whereby, suppose you have some LP, like liquidity provision tokens, and you stream tokens into some. You now stream a Lockup Dynamics. You create a Lockup Dynamic stream towards a DAX, and you're basically saying that I will pay out more tokens in this DAX, more in the future. The more trust I get into that exchange, into that DAX. It's kind of fuzzy. It's kind of like it's untypical, but who knows what people will build with this in the long haul.
Yeah, that automated trading idea is actually really cool. Awesome, cool. Well, I'm really excited to see the code. Should we dig in, or do you want to show us some docs first?
I think it would be good to start with the docs, just to give you a high-level presentation of how the system works and to explain in English, and then we can jump into code.
Awesome.
So should I share my screen, or will you put it on?
Oh, it's up to you. But yeah, you can share your screen. It's that middle button.
All right.
The button.
Can you see it?
Yes, thanks. If you could please just zoom in. It's this platform makes it weirdly zoomed out. It's always an issue. That's perfect.
Is it
Thank
good?
you. Yeah, that looks
All
great.
right.
Thanks.
Yeah, that's perfect.
All right. So just a quick refresher on how Sablier as a whole works. Let's take a simple example. You imagine you have Alice and Bob, and you have a 3,000 DAI stream. Alice puts up the 3,000 DAI in the Sablier contract, and it says the end time to February 1. The allocation of the DAI deposit within the Sablier contract will increase every second in a simple case. And then if we fast forward to January 10, Bob will have earned approximately 1,000 DAI, and he can send a transaction to Sablier to withdraw tokens. And importantly, at any point during January, Alice wishes to get her tokens back. She can do this by canceling the stream, and on January 10, she would get 2,000 tokens back. And on the last episode, we went through Lockup Linear, and including the Solidity part. And Lockup Linear is this simple, cute payment model whereby every second the same amount releases from the Sablier contract. And this is how V1 used to work. This is how most payments are made. Even recurring payments, if you think about them, they are they are constant over time, and that's how it works. But now, in this episode, we will go over Lockup Dynamic, which is the ramped up version of the lockup streaming model that we have, that we potentially call the universal streaming engine. And the reason for that is that it can support any mathematical payout over time. And the examples that we give in the docs is exponential streams, where the majority of the tokens are streamed towards the end of the time distribution. Exponential clefs, So you can have basically no slow buildup, but you can have like a one-time big unlock at some point in time, and then from there it goes again exponential. Or you can also have a more traditional unlock in steps. Here we have a bit of a terminology issue, because is this a stream? Well, if you set the periods to, for example, 1 hour or like 1 minute, I would still call that a stream. But the reason why we count this in the implementation is that it is not possible to exclude models like this, because the contract takes any it can take any numbers as inputs, and you can design the numbers in such a way that they produce this traditional unlocking steps. And what this means is that, imagine you have basically monthly payments, right? You have like a 1 year long quote stream, but then it unlocks only once per month. And this is something that you can stream with you can create with Lockup Dynamic, because it accepts any mathematical inputs. Right.
That
so
could be nice for salaries.
Maybe,
or like
yeah.
If I'm renting an office and I know I'm not going to use it in December, maybe it goes down in December and then it goes back up.
Yes, and you can tweak the period as granular as you want. You're gonna make it 2 weeks. You're gonna make it 4 weeks. You can make it whatever you want. Great. Awesome. So we've been talking about mathematical functions and so forth, but where is the math? I've just shown you some graphs here. The math is contained in what we call segments. And segments are objects in Solidity. They are implemented in Solidity that partition the streaming function in multiple domains. So if you're not familiar with what a domain is in math, it's basically a range of inputs and outputs. So if we were to look at the, let's say at the exponential cliff stream, then here you have only 2 segments. You have the segment between 0 and 50. And this is the domain between 0 and 50, which maps out the outputs based on the provided inputs below. And similarly, from 50 to until 100, you have the second segment. And each partition contains 3 fields. You have an amount, you have an exponent, and you have a milestone. The milestone, I'll start with the milestone because it's the easiest one to explain, is basically the end time of that segment. So in this example, the milestone would be 50. And for the second segment, the milestone would be 100. The amount is the amount of tokens that are allocated for the particular segment that you're looking at. So again, for the first segment, you would have an amount of 20. And for the second segment, you would have an amount of 80. Now, the most important and perhaps the most complicated to explain field is the exponent. Because this is a fixed point number that is represented as a PRB math type, UD2x18. And this stands for unsigned decimal 2x18. And unsigned decimal basically means that you can have up to 2 digits in the integer part and up to 18 decimals in the fractional part. And the reason why we did it this way is basically we ran some calculations and ended up realizing that there's 0 benefits to having exponents, with more than 2 digits. Like if you had an exponent that is something like 100,000, your payment curve would basically be like a vertical bar. Right? So that's why we, for all kinds of reasons, I mean, gas purposes, but also like practical purposes of, you don't need this for the for virtually all use cases. You don't need anything beyond that. And there's a mathematical equation that gives you at any point in time what is the value that has accrued in the stream. And it goes something like this. If you don't know the symbol, it's sigma. So it's the sum of all the elapsed segment amounts. So to go back to the example, if you were at the point, say 60, you wouldn't actually calculate anything in the first segment because you're beyond the first segment's domain. So you can say, I will just consider that segment streamed and I will sum it. And I'll take its value and add it to the sigma sum. Then you have the current segment amount, CCA. And in this example, it's 80. Okay, so in the sum of the first segment would be 20, and in the second segment, you would actually jump into this calculation here. X is the time, and this is a percentage. So if you are, again, to go to this example because I like it a lot, if you are at 0.60, you are basically 20% through the domain of the second segment. And this is because the domain of the second segment is 50 and 100. And that means there are 50 units. So 60 is, you can see visually that there are 5 portions and 60 is at the first portion, right at the end of the first portion. So 100 divided by 5, you have 20% for each part of the curve, right? So you would plug in 0.2 for X. You know the segment amount, which is 80. You have the sum from before. So this would give you something, and now the most important step is to plug in the segment. And I can't remember off the top of my head what segment we used in this particular curve. But the point there, just to keep it very simple, the point there is that you can provide different values for the stream. And because this is a power function, it can grow in all kinds of ways. It can grow quadratically, it can grow exponentially, it can go logarithmically very slow. The point there is you provide a value which is between 0.0000 something up to the maximum value accepted by UD2X18, which I think it's something like 16 or something like that. But anyway, it's a small value because of the solidity types. And that's it. You after you run this calculation, you will be able to plot a function that looks like this. And
that's so cool.
Thank you. And if you're a user along the way in the Sablier UI, and suppose you are again at 60, you will be shown that the 20-something tokens were streamed to you. But in the backend, all of these calculations occur. And by the way, as I said, everything is on chain. We don't have any oracles. This is math implemented in Solidity on chain.
Yeah, if you haven't checked out PRB Math, it's my favorite math library. It's brilliant. Can you do segments have to be continuous, or can I have one from 0 to 20 and then one from like 30 to 60 with a gap?
That's a good question. The segments must be continuous. Yeah. So it's not like an explicit requirement. It's more so that the protocol does not let you specify the start of each segment.
I see. It ends at the previous one's.
Yes.
It starts at the previous one's end.
Exactly. It's the previous segment's milestone plus 1 second. That is the implicit start time of the new segment.
That makes sense.
But that was a great question, by the way. Yeah. In effect, you can achieve. You can have stalling segments by just saying that, between, for example, here you can have a segment between 60 and 70 that has an exponent of of 0, right? Because that would be this value would be 1.
1, yeah.
And sorry, sorry, that was a bad example. You can have a segment amount which is 0, and so CCA is 0. The exponent doesn't really matter because 0 times anything is 0. So with that model, you can have a part of the graph be cancelled by virtue of the fact that you have a 0 segment amount.
That's cool. So if you want to put in breaks, just to refresh your wallet before you stream again, that's nice.
Precisely, yeah. And one thing I want to mention here is that there are a couple of requirements and constraints. So any function must be a monotonic function. In fact, there's no way you can go about this unless there's a bug in a protocol. This is more so like an FYI for protocol developers who start from a particular mathematical function and they say, okay, I want to implement this in Solidity, or I want to implement this with Sablier V2. You can't do it. The payout has to be increasing over time for the simple reason that we don't allow you to rug pull your recipients. They have to be streamed. What has been streamed is law, right? So code is law in this case. All right. And one note I want to also make here before we jump into code is that the exponents are inversely proportional to the rate of growth. That means that if you have an exponent that is 0.5, the rate is quadratically faster compared to the baseline when the exponent is 1. And the reason has to do with just pure mathematics. So if you have a base which is lower than 1, and x is basically always lower than 1 because it's a percentage, it's the elapsed time. And x will always have a value like 0 point something. So if you have 0 point something to the power of a number, a positive number, if that number is greater than 1, the result will be less than the base.
Yes. It's good you mentioned that in your docs, because some people who haven't studied math, it might not be intuitive.
It was counterintuitive for me as well when I first built this. So I sympathize with that. And we actually thought about trying to get rid of this requirement, but isn't like flipping the value such that like a bigger exponent leads to like bigger values. That turned out to be a pain, and it added like a lot of gas costs and many bad things. So we just kept with the pure implementation that works like this.
That is great. I guess if you do want to, like you mentioned, it has to be increasing monolithic. You could just make it logarithmic, and then it does increase, but not as much as it was before. So
yes,
there is the option to decrease your amount. So I think that's great.
That's right. Yeah, we're actually thinking to build like a demo sandbox in like a UI app where you can play with the input values and see what functional plot you get. That's a long way to come, but we will eventually build it because it's kind of hard to. I'll admit that today it's kind of hard to go from I have this mathematical function. How do I port it over to the Solidity part? That's where I have to bridge the gap. It will happen eventually. But I guess in the meantime, we're going to go into the Solidity part now.
Awesome. Yeah.
Would you like to share the screen here?
Yeah, sure.
So I'm asking that just to see you speak because I noticed that before I had a tendency to speak over you because I wasn't seeing you.
Yeah. Here we go. Let me screen share. Can you see it?
No.
Rebecca, can you see it in the backstage of the app?
Yeah, sorry. That should be
okay, cool.
on right now. My bad.
No worries. Would you like to look at the interface or the contract first?
Let's go with the interface. Yes.
That's where your docs are. I mean, your NatSpec.
Yes, that's right. Just as a quick refresher, we have a shared abstract contract called Sablier V2 Lockup, which contains the common logic between lookup linear and lookup dynamic. There are all kinds of functions like query the deposit amount, and all kinds of, like the withdraw function has the same signature, the same interface, the cancel function the same. So to make our code dry, we implemented that contract. So if you want to learn more about how that works, go to the first episode where we delved into that. Here we will only go over the lookup dynamic part, which expands on top of that common base.
Yeah, cool.
And what I have here is the lookup dynamic stream event. There's a bunch of data, as you can see. The segments are, the segment is a struct that contains the amount, milestone, and exponent I showed you before. The range is pretty much similar to the lookup linear part, but in this case, you only have the start time and the end time, because the segments is what gives you the function domains within each stream. And there we go. That's really the event.
Awesome. And then I see you indexed the sender, the recipient, and the assets. So those are the ones that get topics, because that's, I guess, the information you want to see at a glance.
Exactly. Yeah. It's actually like not easy to choose what parameters to index when
also
writing an event. Yeah. But
I leave it up to the front end people and the subgraph people.
Yes. Yeah. Just like, put like a to-do and follow up in 3 months when the UI gets built. But it's like the heuristic that I go with is it a user? Because if it's a user, then they will want to be able to filter their own transactions. And secondly,
absolutely.
Is it like a token, right? Because again, you want to filter by tokens.
Yes.
And once you exhaust that list, then you can think about other variables,
like hierarchies. Sorry, my cat wants something. Cool. So now we have the constant functions.
Yes.
Okay. Max segment count.
This is a protocol level
cool.
configuration to prevent out of gas errors.
Yes, that's great.
So if we will see in the implementation that there's a for loop to go over those segments. So if you remember for the map, there was like the sigma, which was summing over all the previous segments. Well, that is a for loop.
Yes, and that can be dangerous and also lead to out of gas. And
yes.
Funds get stuck.
Yes. Or a for loop or a while loop, but a loop anyway. And when you have loops on chain, you want to make sure that it's always bounded. If it's not bounded, then you're in trouble. And this is like an FYI if you're like a developer watching this. Mind your loops. It's good, healthy advice. So what we did here is we ran some calculations and said, okay, look, each segment costs this much gas on average, and we extrapolated and looked at the 10 most popular chains and look, okay, what chain has the smallest gas limit, and divided that as in the smallest block gas limit. So we divided that by the average value for gas cost for each segment. Yes, and we obtained a value, and then we went a bit more conservative and said that we're gonna go even lower than that. So we said 300 segments should be more than enough.
Yes. Okay, that's cool.
Yeah.
That's a lot.
It should be sufficient, and even with 300 segments, it's gonna cost you a lot of gas. So outside of experiments and research purposes, I don't think anyone will use that many segments. And for context, as it says in the NAS spec, it cannot be changed later, so it's an immutable variable.
Yes.
And immutable variables, they get set in the constructor, and then they remain like that for the entire lifetime of the construct.
Yes. Yeah. Cool. Do you remember which chain had the minimum block gas limit?
It was my colleague Andre who made that estimation, but off the top of my head, I think this was Avalanche. I think.
Okay, interesting.
Don't quote me on this, although. But
maybe I'll take a look this weekend.
Yeah.
That's interesting.
Yeah.
Cool. Then we get range, which is much the same, I assume, as with the lockup linear.
Yeah, it's a boring function.
Get segments.
For the purpose of this video.
Yeah.
The segments are just reading the segment structures from storage.
Okay, that's nice. Get stream from a stream ID. Okay, and then streamed amount of.
This is where the magic happens. And by the way, I do want to make like a quick note here about an aspect. So what I showed you before on our docs website, that was actually automatically generated from what you see here. And I do want to give a shout out to our docs website because we wrote quite a few scripts to automate this. And I highly encourage everybody to not waste any time copy pasting NASPEC into like an HTML website, because you can automate it. You just have to write some bash scripts.
Yes,
and
that's cool.
Yeah, so have a look.
I definitely will. Thanks. That's such a good tip. I usually just use Foundry, but
we're using Foundry as well.
Yes, I just mean the Foundry documentation, but it's nice to actually tweak it and customize it with Bash.
Yes.
I hadn't thought of that.
Yes.
Oh, thanks. Exactly. I'm learning a lot this episode. Okay, cool. So this is the amount that has been streamed to the recipient already, and it's very nice that it's denoted in units of the asset's decimals.
Yep.
I guess it has to be, but yeah.
It could have been normalized to 18 decimals, but that would have been a pain in the ass to...
An extra gas, maybe.
Yes.
Cool. Create with deltas. Is the same as lockup linear, but now with segments?
Yes, this is where it gets tricky. Perhaps this will be the most complicated part of the episode. So the idea is we have two create functions. And if you guys watched the first episode in lockup linear, we had also two functions. There was a create with durations, and there was create with range. Create with deltas and create with milestones are the equivalent of those two functions in Lockup Dynamic. We could have called them the same, as in durations and range, but we didn't want to have any confusion. For example, say somebody starts preparing the function parameters and then only later realizes, hey, I'm not sending these parameters to the right contract. And I just wanted to avoid any silly errors that would result into gas loss and whatever. And also it's a matter of not consistency, but clarity of thought, because the lockup dynamic distribution schedule is super different from the linear one, and the data structures are super different. So we just want to differentiate them by naming them differently. But deltas basically means that you start the stream at the time when the transaction is mined. In concrete terms, you use block timestamp. If you guys know the property, it's available in Solidity. That's the start time. And because of that, your segments are the milestones that you saw in the docs website at the start of the video here, are generated dynamically from the numerical values you provide for each segment. It will be easier when we actually jump into the code to see how the calculations are made. But this is what this function does at a very high level. And then we have milestones below.
Here we go.
And
I see. So now you have in the provided segment milestones. It's not calculated.
Yes, that's right. And here you specify the actual Unix timestamps for each segment. So if we go back in that example with 20 and 80, 20 and 100, or sorry, what was it? 50? No, the times were 50 and 100. 50 would have to be a specific date in the future, right? So now it's September 1. You'd say September 5. And the end time would be the second segment milestone would be September 10. Whereas with the deltas, you wouldn't specify a Unix timestamp. You would specify a numerical value in seconds between each segment. So for the first segment, you can't really do it because that would be you have to specify the end time, but the start time will be dynamically calculated. But the end time will be, you literally say 1 day is seconds, and then for the second segment you would say 5 days in seconds.
Okay, that's cool. And then, if you don't know what a Unix timestamp is, it's seconds from the epoch event in 1970. So you can look up a date's Unix timestamp and then just put that in, I think, right?
That's right, yeah. And there is the 20K32 problem, if you know.
Yes.
Or what was it?
I think 2038.
2038 problem. I want to Google this because, year 2038 problem, whereby the Unix timestamp will not fit into the 32-bit memory, and I mean it will be solvable. I'm sure we'll find a solution by then. But it's funny to think about this. But that in a way,
I think about it.
in a way, if this won't be solved, then Sablier will be dead in whatever in what is it, 15 years?
Well, for 32-bit machines, I suppose.
Yeah, and I mean the EVM is 250.
Oh yes, of course. Yeah.
But you might still have. I mean, the EVM is like an abstraction, so you might have like a node running 52 bits, or and then it will crash because of that. But anyway.
Wow. So many protocols that use Unix timestamps might have an issue. I think about it all the time. It's an interesting one.
Maybe we should switch to block numbers.
Oh yes, maybe. Maybe for V3, but it's so far away that you can. Yeah, it's not a problem for now, but it's an interesting problem to think about. Cool. Let me look at the contract now, if that's cool.
There's a bunch of imports here. As you can see, we like to have specific symbols. Highly recommend doing this. to lower your compilation time. So if you're using Foundry as we are, you're compiling your production contracts, your scripts, your tests, everything with Solidity. So if you import files in bulk, that means that you don't have the name of what you're importing in from, you only have the file name. Then you're importing everything from the specified file, and Solidity will literally compile everything.
And there might be multiple contracts in one file.
Yep. You don't want that.
Yeah, that makes a lot of sense. And then the lovely ASCII. I'm such a fan.
I love
it looks
this.
cool
I
on
like it,
Etherscan.
Exactly. That was the goal. Yes, bingo, it worked.
Yeah.
I mean, it's it's actually like a good thing to when you open Etherscan, the contract name. I actually have a problem with this. That on Etherscan, the contract name is such a small attribute, right? Like,
and when you have multiple open, you're like,
yeah.
Which one am I?
Yeah, and they should put it at the top, like the contract name, and this makes it super explicit that you're seeing this contract.
It's great. Cool. So this is the interface, and then the V2 lockup, which is that I assume that abstract contract that you were talking about. And you explained how you specify how many inherited components there are. I think it's the diamond problem of multiple inheritance.
That's right.
Yeah, and that was something I didn't know before that episode. So thank you. I've been reading up about it and making sure I do it correctly now.
No worries. Yeah, it can lead to all kinds of nasty import errors if you don't do it this way.
Yeah, really good to know. Cool. Yeah.
Just want to say, on a tangent, my colleagues are always blaming me for having them calculate how many imports each contract has. So it's kind of like a chore, but it's worth it because in production you don't you do want to have the proper inheritance structure.
Absolutely.
Which there is a best practice given by the Solidity team. So just follow it.
Yes. Perhaps easy. I don't know if it's easy or quicker, but if you use Sliver, you can Salter UML, that library, you can make a quick UML diagram of the contract, and it shows you how many things it inherits, and then you can just count those as opposed to working it out. But then you need to look at those contracts and who they inherit. So never mind.
I didn't think about that actually. That's a good idea. I was literally manually opening opening each file and manually summing in my head.
I've been doing that too since you taught me this. But now, the other day I was like, maybe I can make it easier, so I got quite excited.
Nice.
Cool. So you use 3 libraries.
Yes,
is
those
this
are
casting from your maths library so that you can switch between?
Yeah, it's syntactic sugar. So if you have you have a UI40, which we're using for timestamps for gas efficiency reasons, and you want to convert that value to a PRB math type, then by using this library here, you can do something really nice, which we'll see below in a bit, where you do dot. So you have the value and then dot into the PRB math type.
Like a UD. Okay, cool.
Yeah, I was inspired by Rust when I wrote those libraries.
That's really cool.
And yeah.
So we've explained what the max saving account is. And then here's the streams. Stored in a mapping of numeric IDs to the stream struct. Is this a stream struct? Yeah.
Yes.
Or is it so the structs are in the interface?
They are in a library. It actually might be worth opening that library now, just very quickly to refresh the memory of the viewers. So libraries. Sorry, types. Sorry, types.
That's okay. Let me do this. No, wait, this is the actual. No, wait, is this? Yes. No.
It's in types.
It's in types. Sorry, I thought this was in types because it's was underneath it. I thought I'd expanded it already. So here's Lockup Dynamic. It's a library. I see. Okay, thanks. I'm understanding now.
We can see it on the screen. It's.
Oh,
now we can see it. Okay.
Now we
cool. I
can.
have to share this tab instead. I'm learning this app that we stream with. Okay, cool. So it's got a struct create with deltas.
Yep.
Cool. Really good to see. And
what I wanted to explain here is first that we're using libraries as namespaces. And that's a nice thing because it lets you group similar types together. So if you didn't have the library up there, you would import create with deltas, and you wouldn't have any connection between this struct and the fact that this struct is connected to Lockup Dynamic, the contract, the system, and so forth. So it's just like a random tip. Just you can use libraries like this, and then we have the struct. The reason why we are putting the function parameters in the struct, I think I mentioned this on the first episode, but I will say it again. It's stack to deep. So we had too many variables to fit on the stack. More than and in the function body there were more than 16 variables in the stack. So you put it in a struct, and then it will do its memory load magic, and it will lower the variables on the stack. But these are basically, that's what I want to say here. These are basically the function parameters.
Yes, I see. Yeah. Okay, cool. And then there's an array of segment with delta, which I think is also a struct, but it's an array of them. Each segment is a struct. Okay, cool.
That's the only difference between the lookup linear function parameters and this one is you have the segments as one input, and same with create with milestones.
Okay, cool. I see. Okay, awesome. I think those are quite self-explanatory. Range. Is this for both, or is this only for the create with deltas? Oh no, a range is just a range. I see. And then you put the range into when you create segment, I'm sure. No, wait, the segment doesn't have a range struct. Where's the range fed into?
I like you trying to figure out, like reverse engineer the process. I love it. But no, it's for both stream types. So the range is basically just it comes at the end of the stream processing, and it stores the start of the stream and the end time of the stream, and that's it.
Okay, great. And yeah, UN40 is more than enough for times.
Yeah, it's like 2 billion years in the future, so it should be should be enough. Yeah, here we have two different structs. We have segment and segment with delta. The reason why the first struct is not called segment with milestone is that the first struct is the what we call the canonical version. That means that the segment of delta is actually turned into a segment, period. Just okay. That. And segment of delta is just a computational tool that is used for processing the stream, and then the segment is what gets stored in the contract storage. And that's why we have a slot. We have comments that specify the storage slots in each struct, but we only do that for structs. Great, yeah, I think it's a nice way to visualize your storage layout. But anyway, yeah.
Cool, and then he has the stream struct, which is similar, but it's just got the segments and the, and it's 4 to, I guess, 304 would be max, but it can be less, obviously, so it's just to n.
That's actually a good point. Isn't we could replace n with 300, but well,
but it won't
300
always go up to that max amount.
Yeah, but like because it's an immutable variable that can have any value you want, so I would just keep it at n. But
yeah, I like the n.
Yeah, the point is we put the complicated data structure which can have like a variable amount of values at the end, so that we can structure the first values which have like a fixed size.
Nicely.
Yeah, to pack them together. Yeah.
That's lovely. Okay, cool. I'm gonna go back to the other contract and.
That's it. Let's go with creative deltas.
Cool. Let me zoom in. Constructor.
Kind of boring.
Is there anything you want to? Okay, cool.
We talked about a segment count. That's the only thing different.
Yes. Cool. Some getters. These are just view functions. Lots of them because there's so much going on. Okay, and I like that there's the is depleted is stream. That's similar to what we saw last time. Cool. User-facing non-constant functions. Create with deltas.
Yep. As I've said before, the segment with delta is just a computational tool. And there is a helper, and we will have to open that sort of to have you switch between so many tabs. But the helpers library implements a few essential functions for Lockup Dynamic, and one of them is the check deltas and calculate milestones, which basically turns seconds into dates.
That's lovely. Okay, let's look at that maybe. Check and create with range. Sorry. Check segments, you said. Oh no, wait, what was it?
Check deltas.
Nice.
Yeah, here we go. Yep.
Takes in the segment array of those structs, gets the length. I see. So this is where you said the deltas are kind of those segments of deltas are kind of translated into just a normal segment, like a milestone one.
Yes.
Okay, cool.
And the milestone is obtained from the deltas. You put in the start time, which is the block timestamp.
Mm-hmm.
And for each segment in the loop, you add the previous milestone to the current delta.
Okay. Okay, cool.
And that's it. You obtain the segments with milestones, which are actually just the pure segments. And then in the create function, if we can go back to that. Yeah. Here you just call the internal function creative milestones. So creative deltas is basically just creative milestones with one detour along the way. And the reason for this is obvious. It's just you want to have just one implementation for the create function, and you obtain the segments, and then there we go.
Okay.
And let's go into that.
The internal function.
Yes. All right, so we have two helpers here at the beginning. And by the way, also the reason why we did this is, again, stack too deep. There were too many variables, so we had to implement some helper functions that are called. They were doing their job, and then we get a value back, and that's it. But here, so check and calculate fees, I think we went through it the last time, but if we didn't, then anyway, it's a pretty simple function. So it just calculates the percentage fees, the protocol charges, which for the record, it's currently set to 0 and it will remain 0 for a long time. And the broker fee, which is a one-time fee that the creator of the stream can charge, and the creator can be different from the user who funds the stream. So you can have like a UI which puts in this broker fee to, make like monetize the protocol. But then we have the creative milestones function, and this is something that it would be worth opening again, because that's where all the checks are happening.
There's quite a few with milestones. Cool. Sorry. I'm just who's in helpers here?
Yeah, in helpers. Sorry for the back and forth.
No, it's okay. I think I put my settings wrong, so I can only do one tab at a time. Cool. Check create with milestones.
Yeah, so I have a boarding check for 0 deposit amount, 0 segments. Okay, max segment count. Okay, check segments. That's where the fun part is. And it's right here. Okay. Okay, so the first requirement is that you don't want the start time to be the end time. You don't want the end time to be in the past, because that wouldn't be a stream. So if the first segment ends in the past, then that's like a one-time payment. You don't need Sablier, so we revert the transaction, so you don't just pay unnecessarily match gas to just to not stream anything.
Yeah, that makes sense.
So that's the rationale. And then this is the part where we calculate the sum of all the segment amounts, and we check that the milestones are ordered.
Okay. I see over here on line 186, if current milestone is less than okay, cool.
I was actually wondering if there's any clever algorithm. If any of the viewers has any idea for this, please ping me, because I thought about. I tried to find a different algorithm that doesn't have an if within a for loop, as in for every iteration, but I couldn't think of any. So we just check that the values are ordered by manually checking that each 2 values are, smaller than the second one is greater than the first one. And the reason for this is natural is, the function has to be monotonic and increasing. So you have to have it ordered. And we calculate the segment amount sum because we need to know how many tokens to transfer from the user.
Yeah, that makes sense. And then you loop it. I can't think of a way to do it without a loop, but it's a very interesting problem.
Me neither. And I maybe some. I was thinking about some tricks with arrays where you gonna have like some hard-coded arrays, and you check if your provided array has matches a certain structure, but didn't go anywhere. So I don't want to talk BS you with ideas, but anyway, current. Yeah. So lastly, check that again, the same check that the milestone is not in the future. The first check was for the first milestone, for the case when there's only one segment. And the second check is doing the same in fact, but you have to do it again because for segments with at least for streams with at least 2 segments, we have to make this check basically because of the way the for loop is implemented.
Okay, cool. That makes sense. And then, you make sure the deposit amount is equal to the segment amount sum, which makes sense.
Yes, it does make sense. Although, if I'm truly honest, this is perhaps the if there is any bad UX with Lockup Dynamic, this is the bad UX right here, because you have to calculate
I see.
each segment amount, and it has to match precisely. And that's a pain. That's a pain acknowledged, but we couldn't find any way in which we didn't bump into other even greater problems. So, for example, one idea was we calculate the delta, so the amount can be greater than so the deposit amount can be greater than the segment's amount. But what happens if you firstly, how much bigger do we want to allow it? Is it 5%? Well, 5% of wrapped Bitcoin is a lot.
Yes.
Right? Then what do we do with that? Do we pay it back to the user, or do we keep it ourselves as, like, I don't know, revenue or whatever? So,
because people will make mistakes sometimes.
Yeah, exactly. So we just said, look, you just have to do your math right, and that's it.
Yeah, I like that. It stops me accidentally making a segment amount sum that's far too small, and I underpay someone, or I make it too big and then drain my wallet. Cool. And then is that the last thing that happens? Wait, we went. Wait, no, we here. Okay, so we went check and create with milestones. Check create. So we've checked it. It's valid. Now we load the stream ID. Create the stream. Obviously, it has to be in storage because it's like a long-lasting stream. Cool. You just set the parameters of the struct, and then an unchecked block. Cool. You get the segment count, end time and start time, and then then you're just pushing the segments.
This is ugly. I wish there were so like Solidity doesn't have like other languages like C++ have a mem copy operation where you can copy stuff from memory, in other places.
Yes.
Solidity doesn't have this so if you have a memory array, you can't just assign it like stream.segments equals params.segments. You just can't do that. It will give you an error. And by the way, a very ugly error. So if anyone from Solidity watches this, please fix this, because I spent 2 hours debugging what was happening, and then I reverse engineered that error and found something on GitHub. But that was very annoying. So please fix this. The solution is basically to just iterate and say, I'll push this value manually into the storage array. That's it.
Yeah, that makes sense. I wonder if it's because of storage issues, but you know how big it is in memory. You know how much storage to allocate. I wonder why they don't have it. Hopefully, in a few years they will.
It's just developer, like, it's just like it can be done. It's just like a matter of figuring out all the details and just putting in the work. So
yes, that would be great. I've wanted something like that often. Cool. Now you meant NFT.
Just so we know, we are like almost 10 minutes past 4.
Okay.
But yeah, you guys just wrap. I think you can conclude this now.
We're nearly done.
Free for now. You can I think just wrap it up. There's no rush, but I just wanted to
cool.
flag it.
Thank you. So yeah, you meant the NFT because each stream is represented by a really cool NFT, and then you save transfer from. Why is that unchecked? Using unchecked
because you have
I see, bounded by the total amount, of course.
Yep.
That's cool. Then if there's a broker fee, you pay it, and you emit an event with, I think it was the sender, recipient, and the assets indexed.
Yep.
Amazing. And everything else, like renounce, I think it's all the same as in the previous episode. So if you want to learn more about that and you haven't seen it, check that out. Awesome.
Yeah,
thank you. This has been so interesting. It's such a cool protocol.
Yeah, it's the first time I actually made like a technical presentation of Lockup Dynamic. I made many presentations about like the basic streaming, like primitive and whatever, but this is the first I went deep into the math of V2. So thank you for having me. That was fun.
Yeah, thanks. I really enjoyed that. I hope you guys have a good weekend.
Cool. Yeah, thank you. Catch us next week for another episode of Solidity Fridays. But yeah, thank you guys. Thank you, Paul. Thanks, Tom. Yeah, have a nice weekend, guys.